coming up next, we've got Péter Földházi, and he confirmed I said that correctly. Maybe I've done it twice in a row here. That's cool. Peter, I can see, is already online over there. Peter is a
EPAM.
lead software test engineer at EPAM Systems, and he's going to be talking about actually, I think, something very near and dear to my heart, which is the flow model versus the page object model, which is something I've been struggling with for a couple of years myself. I don't know the flow model, but I suspect it's going to be similar to something I've done in my past. So, with that said, Peter, take it away.
All right. Thank you very much, Paul. And yes, you pronounced my name correctly again. So kudos to that. I know that it's with all those accents, it's a little bit more difficult. So appreciate that. Yeah. And let me actually start sharing my screen just a moment.
Cool.
And let me know once you can see it. It should be bringing up now.
Yes. Yep, I can
Great.
see it.
Yeah, I can see that. Yeah, so thanks again, Paul. And yeah, let me actually start it. So as Paul already introduced me, I'm Péter Földházi Junior, and I've been working for EPAM actually almost exactly 10 years now. Actually, I celebrated my 10th year anniversary last Saturday. So yeah, now in the 2 digits being together with EPAM. And so I'm a quality architect there. Basically, what that means, I'm a test automation and testing consultant, and I help start projects, kick off with testing and test automation, or if there are projects where with new clients that are struggling with their quality, then I can jump in and have them assess the current situation and improve their quality overall. So that's basically what I'm doing right now in EPAM, but my background was test automation. So for 8 years, I had been doing test automation mostly on all levels of the testing pyramid, doing it on mobiles, web, and desktop as well. So it was fun doing a lot of coding and some manual testing as well. And so what I'm going to talk about is hopefully going to be useful for you, Nikki, and for everybody else as well. So I saw that you're looking for ideas how you can start building frameworks from scratch. So I'm not going to answer that like fully. Of course, that's like a big topic, and probably you need to listen to multiple different topics to be able to really understand how you can design the architecture of a framework and how you can implement it. And actually, I have another talk, the trial your testing architecture. I guess that's more helpful in the in the sense of giving you an idea how you should organize your libraries and test cases to make sure that you can start from scratch and everybody else can reuse your components. But as design patterns are basically helping you in designing your solutions and test automation solutions as well, I'm sure that page object, flow model, and all the other design patterns that I'm going to be talking about will help you in your journey. Okay, so that said, let's get started. So the first topic is going to be about design patterns in general. And as test automation is partially testing and partially development work, I think it's very important that people who are doing test automation, even if they are test automation engineers, developers, or testers, or whatever positions they are in, they still need to be aware of some of the design patterns and the design principles. And so when people talk about design patterns, most people talk about the Gang of 40 design patterns. That's what they think about first, or that I think that's what people should think about first, because those were published in 1994, and we are still leveraging those design patterns, and it's really useful. And actually, my favorite one is the facet pattern. And one of the reasons is because it's actually used in all of the test automation specific design patterns that I'm going to show soon. And so what is it exactly? So the facet pattern helps you hide implementation details and basically provides you services called facets that your other libraries are going to use. So in this example, I have a login flow. A login flow is going to use the facets of the main page, the login page, and the profile page. So I'm already pointing to the page objects, which I'm going to go into more details later on. So the flow model is going to leverage those facets. And the facets of the login flow are going to be leveraged in these test cases over here, and probably in many others as well. So we basically are not really interested in the implementation details. You just want to reuse certain services that these facets are providing. Of course, you might be the one who implemented it, and in that sense, you are interested in. But when you are using them, you just want one line instead of 10, 20, or how many lines you have behind it. Okay, so I mentioned that test automation specific design patterns are leveraging the facet pattern. The first and most popular and most known one is the page object, which was invented by Simon Stewart and his co-workers sometime at the beginning of the 2000s. And so this is something that if you go and interview to a company for a test automation role, I think in almost all of the interviews or most of the interviews, this is going to be a question. What is a page object, or how do you implement a page object? So there's probably going to be a question about it. So it's very important for test automation engineers to learn about the page object and to actually use it in their work. And so the second one that was invented by Anthony Marciano a couple of years later, around 2007 or 8, was the screenplay pattern, which is actually leveraged in Serenity BDD. And so they had a couple of issues with the page object that they wanted to address. I'm going to talk about these issues a little bit later. And so that's why and how they came up with the screenplay pattern. So next up is the flow model, which I invented 9 years ago, actually more than 9 years ago. So it's been time now. And so I'm going to share more details about it a little bit later. And the last one that I mentioned here is the UI objects, which was invented by my ex-colleague, Roman Yevlev. And so how these are different from each other, uh, high level, is that the page object focuses on how you organize your pages. The screenplay focuses on how you organize your users. The flow model focuses on the user actions. And the UI objects focuses on how you operate the pages. Okay, so that's in a nutshell about design patterns. And let me just have a sneak peek to whether there were any questions so far or not, but I don't see any. So let me hop back to the presentation. Okay, so next topic is the page objects. And so for me to be able to really show what the page objects are and why is it useful, let me first show you an unstructured script. So what do you think when you look at this piece or pieces of code? Probably at first you don't know what exactly this is. Eventually you will figure out that probably this is a test case and this is a successful login scenario. So, but you need a couple of maybe a couple of minutes to really figure out what's going on, what are the different steps that you are taking. So this is not really intuitive when you look at it. So of course, it's not an ideal scenario, and hopefully nobody uses that in a like a long-term automation project. But for POCs or just getting started on your automation journey, it's fine to have such a test script, just one or maybe two, but not too many more. And make sure that you start leveraging page objects or parameters later on. So yep, this is how my face looks like when I see people still using unstructured scripting in their uh, serious test automation solutions. Okay, so how does the page object help you with that? So the page object is basically it's providing models, class files for each of the pages that you're going to interact with. And each of these class files are going to write down the elements that you're going to interact with and how you can locate them. It's simple as that. And you can have like all sorts of different buttons, speakers, images, text fields, and so on that you are going to test. You're going to check whether they are there. You want to click on it, or you want to type a text and proceed sending that text and see what the reaction is going to be from the website or the mobile application. So that's what the page model is really about in a nutshell. And so how it started, as I mentioned earlier, uh, it was invented around the beginning of the 2000s. And so the idea came from the web driver, I mean, the Windows driver, window driver that came from Martin Fowler. Actually, Simon Stewart and Martin Fowler worked in the same company at the time, and that's how Martin was able to influence Simon and his colleagues. And the first speech about the WebDriver and the page object was in 2007. And that's basically the time when Selenium was born and became public. Okay, and before I move on with a little bit more about the page objects, it's very important for me to talk about solid principles. So just like design patterns, design principles are very important as well for developers and test automation engineers alike. For example, OP principles and the select principles. Typically, when I interview people or we have a promotional assessment for people who want to grow to higher level of test automation, then we typically ask this from seniors or more likely from lead engineers. So I don't think that it's necessarily important for juniors or experienced test automation engineers to know that these principles, but they are actually really useful. So it's good to read up on them. I'm only going to be talking about the first one, the single responsibility. So on the left side, you can see a bunch of shapes in one pack. So that represents one class file, which is going to describe you how you can create and interact with these different shapes, such as the triangle or rectangle. And so why I have them in these one batch and like in one class file is because this is actually an anti-pattern, and this is not really recommended. And this is the example that if you want to make any changes in the rectangle, you are going to make that change in that one big class file. So what's going to happen if you didn't design your class file correctly, or when you make the change, you are not careful enough, you might introduce changes to the other shapes as well, not just to the triangle. And you might actually introduce bugs this way. And s- that's one of the reasons why it's not good to pack everything in one class file. The other reason is because it's going to start growing bigger and bigger, and it might be a couple of hundreds of lines of code, or maybe even thousands of lines of code. Unfortunately, we have seen many such examples in public repositories, and it can be a nightmare to work in such class files. So because of that, Uncle Bob recommended to separate the concerns, and instead of packing everything in one class file, why not have three different class files for these three different shapes? They can still inherit a shape class file to make sure that there are some commonalities between them. But when you want to make a change just in the rectangle, then you're going to change just that class file. This way, you are making sure you're never going to touch the other shapes at all when you want to make a change in just one of them. So, and of course, they are going to be much smaller, much more easy. It's going to be easier to read them and to maintain them. So the benefits are there, but there's still one question. So how do you, of course, in this example, it's very simple. But when you think about your examples in your production code, in your test code, how do you determine the different responsibilities? It's not always this trivial. And so Uncle Bob was thinking about it for years, how to best describe it. And I think it was somewhere around 2008 or maybe later when he came up with a very good explanation. And what he said is that you need to think about from who, from where the request for change comes if you need to make a change in your class file. And that said, let's think about the page objects and the different responsibilities and who are responsible for these different aspects of the page objects. So we know that page objects typically include locators, which you're using to locate the elements. So you store the elements as well. You also have the actions in those page models and potentially concatenated actions, which are the user flows. So I will give you 30 seconds to think about who could be the responsible people. And don't be shy, write it to the comments. I'm really curious what you think. Okay, I don't see any comments yet, but if you have any opinions, any ideas, please share it with us. All right, I think I gave enough time, so let me share my version. So for the locators and elements, typically it's the developers because they are the ones who build the application. So if there's a change in the DOM, then the locators are changing, and because of that, the elements are changing. So anything regarding the locators and elements, any change is going to come from the developers. So they are the responsible people. For the actions and user flows, of course, it depends on your company culture and especially the project setup. But if you, for example, you are leveraging BDD and like actual BDD where the scenarios come from the business owners, then you could say that the actions and the user flows are coming from the business. But most typically what we see in like almost all of the cases, it's actually the testers who provide the test cases and the actual test steps and then user journeys. So I would say that typically for the actions and user flows, it's the testers. So that means that there are at least two different source of people or group of people from who change may come when you need to make a change in your page models. So that means that there are too many responsibilities and it breaks the single responsibility. So that's basically the biggest concern of people who brought this up, that there's necessity for making change in the page objects. That's why the um, Serenity team also came up with their solution, and they also say that it breaks the open closed. I don't consider that actually that big of an issue, or I'm not fully agreeing there, but that's okay. I don't agree with the part where people say that it breaks the Yagni principle, because the Yagni principle means that you ain't gonna need it, which means you're going to, because there are people who create really big page models. They store all the locators, all the elements of each of the pages, but they are not actually exercising all of them in their test cases. But actually, is that the issue with the page object model? I don't think so, because the page object model just tells you how you can build your classifiers for each of these pages that you're going to write tests for. But who is responsible for defining which elements you're going to interact with? It's those who are writing those page models. So actually, it's you who is responsible for that. If you are not following the Yagni principle, it's you who is breaking it. It's not the page object. And lastly, it's not like closely connected, but the page factory is not recommended anymore. Well, it's closely related to page objects, but it's not the page object itself. But it's something that I see that people are leveraging it, and maybe in small projects it's not a big concern, but on bigger projects I have seen people coming back from using the page factory and instead just building their own. Okay, so I will pause here a little bit and check whether there are any questions. But I don't see any questions yet. So in case you have any questions, feel free to ask them. I'm very happy to answer them during these like little breaks. Right, so let me go back to the presentation and talk about the flow model pattern. First, focusing on UI test automation. So I told you that the page object is breaking the single responsibility. And so how can you fix that? I will give you a very good example for that, a very simple one. So on the left side and on the right side, you'd see two similar but a little bit different houses. So on the left side, that represents the page object. So there's a facet here, and this facet involves all pages, user actions, and everything else. So everything is stored here. Whereas on the right side, on which represents the flow model pattern, now you have two levels of facets. So you have the pages here, the smaller ones. You have a bigger one above them, which represents the user actions and user flows, which are going to leverage all the pages and the widgets. So how does that look like in practice? Before going into those details, let me show you what a UML state machine diagram is, because that's going to help you understand the flow model pattern a little bit more easily. So UML state machine diagram has basically states and transitions. So in this example, I have a soda machine, and what I want to do is I check the list of drinks, I select the drink. So I get from one state to another through a transition. So now I'm there at the payment. I insert the card, I get to the confirmation, and also I get my soda. So that's great. So this is a simple state machine diagram, and this is basically how they look like. Now the reason why I mentioned it, because the flow model is like, if you want to show it with diagrams, then it's basically UML state machine diagram. So you have all sorts of different screens or pages, and these are the pages that you're going to interact with. So you have your interactions, for example, the click actions. So you click on the login button, you're on the main screen, you get to the login screen through clicking on the login button. Then you type in your credentials, you remain on the login screen because whatever you type in, it just remains there. Once you click on the continue button, and if you gave proper credentials, you get to the profile screen. Then you can do whatever you want, edit your profile, or if it's, for example, a bank wealth management application, you can check your portfolio, or if you can make transactions or buy anything, you can do that there. Once you want to log out, you just click on the logout button and you get to the main screen again. So that's how it's different from the page model, because the page models include all the actions inside page models. So the screens and the actions are together. So you don't really get to see where you're going from. You see where you are, you can see what you're doing, and you just get somewhere. In the flow model, you see how you get from one screen to another. So what's actually going on in your entire system. So giving you a little bit, a slightly little bit more complex example, let's go with an Android example. Let's say that you're on main screen, you want to, again, log in. So it's the same scenario, but now you have a toolbar widget. So on the top, in the toolbar, you find the menu button. So you have that menu widget there. So what is a widget? A widget is an element that can be represented on multiple different pages. So typically, like for example, a login widget. In this example, actually, I don't have a login widget. I have a separate login screen. But here, for example, menu button, the hamburger button is going to be there on all pages. But it's not, so because of that, you still need to be able to interact with it on each of the pages. But it's not dedicated to just one page. So you need to handle it as a separate class file. So that's what widgets are. So you have a toolbar widget, you have a menu widget. So when you tap the slide menu button on the toolbar widget, which is on the main screen right now because you are on the main screen, then the menu widget opens up. That's where you tap the login button. So you get to the login screen. You do your login, you click on the login button, you get to the profile screen, you do whatever you want inside the application. Once you tap out the login button, logout button, which is again on the toolbar, or you could have it in the menu widget as well. In this example, it's in the toolbar. Then you get to the main screen again, logged out. Okay, and so let me actually check whether there are any questions, but I don't see anything. In case you have any questions, if anything is unclear, just make sure to like speak up, like write your questions, and I'm very happy to have some more, like provide some more insights. Okay, so next up, how does so where do you put these flow models? So I'm showing you a tri-layer model where you have your test scripts on the top layer, you have your app independent libraries on the bottom, and in between you have your business logic, basically all the application dependent libraries. And that's where you are going to have your flow models and your page models as well. So I call them structure models here just to distinguish them from page models, but they are basically still page models without all the user actions and user flows. And yeah, that's exactly what I mentioned here. So you have all the flow models and structure models in the business logic. Okay, let me give you some examples. So the first example is going to go along this tri-layer example and the login example. So I'm leveraging a tri-layer architecture. So I have a base screen, base page that all these screen models are going to leverage. I have a user action which the base flow is going to leverage, and then the login flow is going to inherit all what's inside the base flow. Okay, and basically the login flow is going to leverage all the facets of these screen models and widget models, and the login test is going to leverage everything from the login flow, so all the facets that the login flow provides. Okay. Going onwards, how does it look like in coding? So this is going to be an Android example, and you might remember these couple of lines of code from a couple of slides earlier, where I showed the unstructured scripting example. So of course, this is not so nicely looking, and it's not so maintainable. So you have to do something in order to make it work in the long term. So what do you do first? So your first iteration should be creating your page models. So you create your page models, and what you do, you create your elements here, and all the like username, login button, password, show password, whatever else you want to store, whatever you are going to interact with in your test cases. So next up, what you're going to do is using them in your test script. So now your tests are going to look much different. So the part where I'm leveraging these previously shown uh, elements are going to look like this. So now it's a little bit more easily understandable. So when you look at it, now you know where you are. Remember that the flow model is basically a UML state machine diagram. So you know now you have the state part, where you are at, which page you are interacting with, and which element you are interacting with. So you already have that now, the what part. Okay, next up, you want to know what you are doing, so where you are going. And so for this, you should create your flow models, one or a bunch of different flow models as well. In this example, I'm only showing you one flow model, the flow login flow. So you have different methods here that are actions, user actions, and you can see that they can have like one or two or even more lines of code. So you can concatenate steps. You can have the actions, and you should have these actions because when you do a certain action, you also want to validate what happens. Okay, of course, that's a deeper discussion as well, but in general, that's what my recommendation is. So how is your test going to look like after this? So now what you see in your test, you see what user flow you are going through. So you know what you are doing. You are logging in. Whether that's a successful one or not, of course, that's something that you have to still figure out. But when you look at it here, you see that you type your username, password, you finish your login, you want to check whether you logged in as Darth Vader. So probably that's a successful scenario. So now you can do a lot of different things. In this case, just simply logging out. And how does it compare to all the other implementations? So the unstructured is much longer and not so readable. You don't know where you are and where you are going. And on the page model, actually here you already know where you are, which elements you're going to interact with. So it's already maintainable, readable. So that's pretty awesome. But in the login test, you know what you are doing exactly. So you know that what test you are executing here. And that is the power of the flow model, because ultimately, when you are doing test automation, it's still a testing activity. So you have to think with a tester's mindset. And in my opinion, if you're doing a test automation activity, you are part tester, part developer, and that's how you become a test automation engineer. So, and that's why 9 years ago I came up with the flow model, because I wanted to understand my test cases, even if I came back to those test cases a couple of weeks or couple of months, or maybe a year later, I was still able to understand what exactly was going on in my tests. If I wanted to understand where am I just always went into the implementation and checked which page model it's interacting with and which element of those pages. And if I wanted to make any changes, let's say the DOM changed, I needed to make an update, or user flow changed, and I just went into those given page models or flow models where the change happened. So everything uh, is easy to maintain because of that. Not just the pages anymore, but the actions and the user flows as well. So any questions to what I have shared so far? I'll give you a little bit of time to come up with questions. If not, then I can continue with the presentation, and you can post your questions in the meantime. And we can come back to those questions once finish the last part of the presentation. So let me do that. So uh, in the next section, I will focus more on the end-to-end testing and API. So not focusing on the UI at all, but of course, you could still include UIs as well. So I wrote here, no UI, no screen, and page models. So in this example, that's what I'm doing. Of course, in end-to-end testing, you could have a combination of UI, API, and DB testing, and so on. So what am I going to do here? So I'm going to make a little bit of change of how the flow model looks like. So previously, we had flow models and structure models, right? So we had these structure models because we had a graphical user interface to interact with. But if you don't have a graphical user interface, but you do have APIs to interact with, then you should have utility classes where you describe how you can interact with those APIs. So let me give you one example. And in this example, uh, let's think about someone with a bank card, let's say with a credit card, who has an account at a given financial institution and wants to make a transaction and either accidentally gets suspended or for whatever reason, maybe someone stole a card or just couldn't find that card, so gets the card suspended. After that, wants to make a transaction. So we want to validate that this transaction doesn't go through, but then finds the card and let's see whether we can suspend that card and do a transaction after that. So how does that look like? Now, in this example, you see we are leveraging more than just one flow model. So account flow, suspension flow, transaction flow, again the suspension, again the transaction, and again the account flow. So three different flow models. And again, it's very easy to understand what's going on. So you know that you have a user, you want to log in with that and validate that it has a valid card. Okay, so it has a valid card. That's cool. Let's suspend that card because if there's a valid card, you can suspend it. And then let's check whether that suspension went through or not. After that, try to make a transaction, validate that it's suspended and that you couldn't make a transaction so that it's denied. After that, let's try to unsuspend the card, validate that it happened, and do that transaction, the same transaction again. And let's hope that it's a successful one now and whether the balance decreased. Okay, so this is so when you look at this test case, you know exactly all the test steps that are happening here. Still, you might want to concatenate some of the steps, especially validations, because you don't want to detail all of them in your test script, and especially if you reuse them a couple of times. For example, validating the successful transaction or for example, validating that the suspension went through. So where are you going to validate the suspension? You're going to validate the response itself and like the response code, the response body. You're going to validate the database as well, and you're going to check through the logs. In this example, I chose Splunk for that. So you are going to check those logs as well, whether the actual suspension went through. So you still might concatenate a couple of different steps here. When you look at the test case itself, you only care about validating the suspension. That's what you're doing. But what exactly you are doing beneath that or like, within that can be stored inside a facet. Okay. So to sum it up, basically the flow model is not bringing the single responsibility. It leverages facet patterns just like all the other test automation specific design patterns, but it actually leverages a double facet. That's how you can you can follow the single responsibility and make your code easier to read and easier to maintain as well. So because of that, it's easier for newcomers to ramp up. This is actually what happened in, that was at the end of 2014 when I had a team of junior Android and iOS developers. So they just went through a mentoring program, and before starting a project as developers, they wanted to learn about test automation. They wanted to like improve there as well. So they joined my team as test automation engineers. And even though they were fresh juniors, they were able to be productive already on the second day. So first day we had uh, like I had one-on-ones with them. Next day they already produced test cases following the flow model pattern, and everything was maintainable. So it's really, really quick to learn it. And it's also the good thing is that you can leverage it not just in UI testing, but in all sorts of different other testing end-to-end scenarios where you leverage APIs or even database and other testing as well. The downside of the flow model pattern is that you need experience. So when you do it for the first time, and if you are not a tester, you don't have a tester's background, and you don't have the knowledge, the domain knowledge of that product that you're going to test, it's going to be more difficult for you. On the other hand, if there's someone in your team who does have the domain knowledge, and let's hope that there is, otherwise it's overall the quality is going to be low if there are no people who understand what the product is. So yeah, let's hope that there's at least one person who can help you uh, define the different flow models, and together you can design it. And the first couple of times you're going to do it, it's going to take a little bit more for time for you to design it. But once you get the gist of how to create flow models, next time you are working on a new project, it's going to be much easier for you and much quicker for you to leverage flow models. And that's it. Thank you very much for joining this session and listening to my presentation. I hope that you will be able to take away something, and the next day you're going to be able to leverage it in your work. And if you have any questions, please write it in the chat. I'm very happy to answer all the questions that you may have. And if you want to read more about the flow model, I'm actually going to write a couple of articles about it and we'll publish it on my website. And I plan to publish articles about other test automation related topics as well. You can find me on Twitter, LinkedIn, and all my videos are on YouTube. And I would like to thank Sapotec well, for organizing this online meetup. And I guess someone is waiting me over on the other line. So that's all.
You,
Thank you.
looks like you do have a question out there. We've got one from Alex Sidyakin about page objects or app actions in Cypress. I'm not sure how much you know about Cypress. It's a little not quite. I can't speak to it on that. So, what's if there anything answer you can give on that?
To be honest, I'm a little bit confused on the question itself. So if you could clarify, Alex, whether you mean, because I guess you mean which one is more preferred, the page objects or the app actions in Cypress. I won't be able to answer that question because I need clarification. But to be honest, from my experience, so I've been using Selenium. Okay, thanks, Alex, for the clarification. So I think if you're leveraging Cypress, probably it's better for you to go with app actions, right? Because that's what's being leveraged there. So it's probably going to be easier for you to go with that. Uh, in general, I think the page objects is pretty nice. As you could see, it can be improved. And so if you follow the flow model, you already have the page models. You just wrap the flow model around it. So, and you are going to take the responsibilities, part of the responsibility of the page objects. So if you follow that, I think you're going to have more powerful page objects because you only are going to focus on the locators and the web elements and nothing else. So I hope that probably it just partially answers your question, but I hope that it answers it.
We just a reminder, we've got about 15 minutes left. So if you've got questions on there, please write them in there. During that time, I actually took a few notes while I was watching this. I wanted to bring up something that Peter actually mentioned that not a lot of people in automation notice or know about automation, which he mentioned that tri-layer architecture. Um, and most people think, well, it's just a test case and it's all record and playback and it's all that. At least the freshers do. um, 3 layers is always what I'm always looking for. Your test cases, your business rules that you have in the middle, which is what processes are you going through, and then the last layer where you're supporting everything. So um, in my case, I'm always writing wrappers for select, enter, and click, and then putting in stuff in there that kind of makes the framework more reliable as it's interacting with elements. Um, and uh, that's really a good layer. I think of it like a 3-layer cake, and when you're looking at stuff, and
Oh yeah,
it just breaks down at least 3 layers. In some cases, if you go to Cucumber, you go to 4 layers. I don't like going that far. I'm willing. Cucumber's great. In my project right now, I don't have any cucumber. I keep it to 3 layers, and it's exactly as Peter's got out there, where you're breaking it out into the different pages and states in that flow model.
yeah.
One of the yeah, go ahead,
Just
Peter.
one more thing to add to that. Actually, I had a well, not a previous, but a previous version, where I actually had a couple of different topics, like the flow model, the tri-layer testing architecture, and test case selection. I think it was, yeah, these 3 topics in one presentation, and that was in 2015. And in that version, I represented the flow model. Like, I have these for each of the chapters. I have uh, mm, picture about different rock formations. And in that one, I had a layered cake. Uh, and it looked, I think, really awesome. The only thing was that when I presented that one the first time, then it was lunchtime for everybody
Oh,
else.
you got
Yeah, and they were right to be like, oh, it looks so nice, but it's so painful to look at it while being hungry. So
It's called lunch and learn, people. We have lunch. You bring your lunch. You sit there and watch the whole thing. Oh, it's good.
yeah.
Yeah, actually, I did the same thing. With mine's actually an upside down layer cake. Things are kind of getting smaller because they're all using things at the bottom layers and then coming back
Mm.
up to the test. Um, yeah, let me think. What was some of the other stuff that you had in there that was good? Uh, I'm actually working with a flow that I've had recently that hang on a sec. Before I say that, we had a question coming in from Nikki over here. I know it's not
Sure.
related to this presentation, but I really want to ask, what is the main difference between test cases and a test plan? Peter, you want to take that?
Okay, I'm guessing that this question comes because of QC. That's my assumption. But yeah, it's a little bit a deeper topic again. There are big differences. So first of all, what is a test case? A test case is, if you want to describe it the simplest way, it's basically the steps. It describes the steps that you're going to take to validate a certain functionality or set of functionalities. So it can be a simple atomic test case where you have only one test step. What you have a precondition, you have an action, and then you have a postcondition, which is basically the validation. This is exactly what we see in the Gherkin language as well. Given, when, then. That's the given is the precondition, the when is the action, and the then is the assertion, validation, however you may call it. But okay, so that's one way to describe it. Or you could have, like, just like in the flow model, you have a bunch of different test steps. Some of them are simple ones, some of them are complex ones, and you concatenate them, and you have a long user journey which helps you validate not just one functionality, but like a whole set of functionality, and this way you can have a bigger coverage of validation for your application or for your service. That's how you can create test cases. Now, test plan. I'm guessing that the question comes in because in certain test management tools, you can select a test plan and decide which test cases and test suites you are going to run. So that's my assumption that the test plan that you are referring to is that test plan. So basically the test plan is the plan for that release where you are going to do your release testing and you are selecting which test cases you are going to test. That is all. On the other hand, and that's again, I think for if you go for an interview, uh, this is something that especially for, I think, functional testers, manual testers, or especially for test managers, this is a common question. What is the difference between the different kind of test plans? So what is a test plan? Or what is the difference between a test plan and a strategy? So when I think about test plans, I don't like to think about it as the plan for that release. So there can be a release test plan. I like to think about it more of like a project test plan because with Agile, we started moving away from that waterfall way of thinking. In waterfall, for what you did, you prepared for really long, robust testing. And you might have had like different stages, which took not a couple of days, probably a couple of weeks to go through. Now in Agile, and especially with DevOps being more prominent, what we are trying to enforce is decreasing the time spent on testing and still being able to cover as much as possible. Obviously, that's a pretty tough situation for us testers. So when we create a test plan, what we try to focus on is what we are going to test. Well, so what is the product? Why we are testing it, how we are testing it, that's the strategy part. It could be project specific or better to have it as organization level strategy. Again, that's a different discussion. And then when are you are going to test and where? And yeah, so if you can get to a point where all of your tests or most of your testing is automated and it's in the pipeline, in a single pipeline with your application or service, then basically your test plan is going to be a really small document. And you're basically describing how you integrate into the pipeline and what are the environments that you are going to test against. And some more questions are going to be answered there, but this is how it should look like. And I know that I gave a little bit wider answer to this question probably, but I hope that this amount of information was useful.
Yeah, I think you hit it right on the nail there. Nikki's actually asking, the test plan. I had expected her to actually throw in there, the test strategy. Peter, you're totally right on there. The way I should think about it is, the test plan is your scope, what you're going to be testing, what areas, what you need, what kind of data, defining what the process is going to be. When you get to the actual test strategy, it's how you're going to do it. Uh, what's our in my case, I'm looking at in coding standards to how we're going to put this together. Um, it also brings up a point that I was thinking about, and Nikki says thank you. That's great. Um,
Sure.
one of the current challenges I've got, I had was, I think I mentioned the first half of this, is that at my current job, I'm actually creating loans, mortgage loans, and there's a flow that basically goes through. What kind of, is this a refi? Is this a new one? Are you buying as your own on your own, or do you have somebody else with you? And then the branches just become incredible different logarithmic branches of the whole thing, and it's hard to build a test case out of that. Um, or so many of these. So what I've because this path, some of the pages you get to, depending on what you select on one page, the next page may not be the same, may not be what you expect. So what I've been doing myself recently is I've got basically a loop that says, all right, process whatever page I'm on, click the next button. What page am I on? Process that. And it loops and basically navigates its way through the whole thing to the end. So if a page is missing, doesn't matter. If the But the only thing that breaks is when a brand new page is introduced, and then I've got a little bit of maintenance versus a test case where we're going from top to bottom, and then all of a sudden you got a new page in the middle, and I got to go fix that, or one got removed, and then you got to say, okay, ignore this. Um, so that's uh, the flow is really a really big thing to consider on when we're doing that. And I think Peter did a great job on explaining his process on that. Definitely will come in handy on that. Uh,
Great
we
stuff.
still have about we still have about 5 more minutes,
Mhm.
and let's see if there's other questions or anything else I can throw in there and ask you. Um, well, I tell you what, at the very beginning, uh, uh, you're welcome, Nikki. Um, at the very beginning, you actually talked about, we have the page object model, page factory, which is kind
Mhm.
of going away. Can you give us some tips on the big challenge where our elements are changed by developers? They make slight tweaks to what's
Mhm.
the element is, and our locators. What can we do to kind of reduce the maintenance on our
So,
locators to handle that?
yeah, so obviously, so page models helps in the fact that if you need to change it, you only have to change it at one place. But that's still not enough, obviously, because if the DOM changes frequently, now you can do two things. One of them is to find another locator strategy that might be more stable. So typically, one mistake that we can see is that people come with like very like a static XPath, and then they they are surprised that every day they have to change it, or even every like couple of times the same day. Obviously, if you choose a locator, which is a static locator, instead of trying to just go closer to what exactly is the element that you want to interact with, um, then it's going to be unstable. On the other hand, sometimes even that is not enough. And what can help is some sort of machine learning solution. So for example, the Selenium, if you search for Selenium.io, provides such a solution. So that's an open source framework based on Selenium. And so why is it Selenium? Is because it's a Selenium which itself. So if there are any changes in the DOM, it's able to detect the change that it didn't, so it's not going to pass. So it tries to find an alternative that is very close to that original locator and tries to execute that part with this new locator. And if that doesn't work, then it will still try other alternatives. And there's kind of a chance of which one is going to be like more likely to pass. So that's basically how it works. So that's what you can do.
That sounds great. Sounds a lot like what I've been doing for 15 years. Somebody owes me some internet money. Uh, I do
Says
the
that.
same thing. One of the big recommendations I tell people when they were doing this, creating locators, and what Peter described, his very first example is when you see something that says something like div/div/div3 div/a, and you get a link and then that path gets broken. It's horrible. Uh, the thing that I tell my team members is when you're writing your locators, don't make them exact. Like, don't say if you're looking for add to cart, don't just say text parentheses equals quote add to cart. Put the word cart in there, and then just say, okay, let's see if we can say text contains cart, and I put in a little code in there that says, okay, hopefully we only found one match on that. If it's like two or three, then very similar to what Peter was describing with Selenium. it goes through and says, let's try a couple of different ways to try and find a single match of an element that's out there. So be generic. That's the best advice I can give you on locators and stuff.
Yeah.
So that brings us up right to the end of our session here. Peter, I want to thank you so much for joining us here. It's been a pleasure speaking with you.
Yeah, same, Paul. Thank you very much for the discussion. And yeah, thanks for pronouncing my name correctly twice. Really
Thank you
appreciate
so
that.
much. I appreciate it. And we'll see everybody next month in August. Have yourself a great day and stay safe and healthy, everybody. Thanks. Bye.